Welcome to Lauterbach-Verfahrenstechnik. Today we will have a look at a proof of stability and we will consider nozzle loads and seismic loads. In the previous video we had a look at this vessel with 4 nozzles. 2 nozzles on the left and the right, one at the bottom and one at the top. This time we want to have a look at the leg support of this vessel. We want to calculate the loading of the leg support. We know that at each nozzle there are forces and moments applied. We know that there is superposition of all those nozzle forces and moments, and we want to consider the earthquake loads. So the 2 questions that we want to answer are if the leg support withstands the mechanical loads and to what extent the vessel bulges. Our solution will be using 3 modules. First of all, the earthquake module, then the second module which has a look at the superposition of the applied loads, and thirdly, the module about the vessel on leg support itself. Here you can have a look at the interface of our software. On the right side you can see the module with all the data that you put in, all the data that will be calculated, and on the left side the list of all the modules that you are using. The most important inputs in the earthquake module are boundary conditions and earthquake impact. The results are shown here, and especially important for our task is the horizontal constraining moment, which you can see here. We have a really practical function which is saving and remembering certain values. So for example, if you want to use especially this value in the next module or in all the other modules that we are using from now on, then we can save this value and use it in other modules. And if there are changes made in this earthquake module and this value, horizontal constraining moment, changes, the changes will also apply to the other modules in which we use this constraining moment value. Then we go on to the load superposition module. We put in the nozzle geometry and the loading, which are the most important inputs in this module. Of course, there are many other inputs as well that are necessary. And here you can see the results table of this module. On the right bottom side, you can see the additional shear force, which is the input from the earthquake module before. And as I already mentioned, if we make changes in the earthquake module, and especially this value will change in the earthquake module, all the changes will also be applied to this value right here. For our task, it is very important that we remember the total shear force and the restraining moment. We can also use the function to save the parameters here. And the third module will be the FELV module. We put in the type of model, the material data, geometrical data. Also the boundary conditions are very important. And here you can see the restraining moment and the total transverse force from the module before, which are also put in here and saved in the other module. Which means if you change the values in the module before, the values here will change as well, just like in an Excel file, where you connect values to each other. And here you can see the results and stresses which are transmitted from the calculation interface to our module. We can see that the maximum utilization is about 87%, which means that our vessel and the leg support will withstand the mechanical stresses. Here you can see the calculation interface. In the middle you can see the model of the vessel. You can turn it around, you can zoom in and zoom out if you want to. On the left side you can see all the geometrical data that you put in the module, all the other data. You can also see the results, so the stresses, the utilizations. You can have a look at the net for the analysis, stress analysis. You can zoom in and zoom out on the interesting parts. You can have a look at the deformation, at the von Mises stresses. You can also have an isolated look on the different parts of the model. You can have a look at the reinforcement. On the right side, you have the option to adjust the lower limit isoclipping. For example, if you put the boundary to 111, then you will only see the stresses above that value. You can also adjust the maximum of the color scale. You can perform a buckling analysis, which will show you where and how strong the vessel will bulge. You can also turn around that model. You can zoom in and zoom out. You can see the critical load factor. And it will also appear in the results table. If you change the data of the input, if you change the input in the module, the data in the calculation interface won't be actual, it won't be correct anymore, which means that you have to click the read data button at the top left, and then it will give you the new data. For example, if we put in a different diameter, a different form, a different shape, then you can also, as I just said, click the read data button and all the values will be correct again. Thank you very much for your attention. If anything was unclear, if you have questions, then you can always feel free to ask them either in the comment section of this video, or you can always call us or contact us via email. Thank you very much and see you next time.